Every day, our brains are bombarded with a whirlwind of experiences. From the moment we wake up to the time we go to bed, we encounter countless sights, sounds, and sensations. Yet only a small fraction of these moments become lasting memories. So, what determines what we remember and what slips away? The amygdala, a tiny almond-shaped structure deep within our brains, plays a crucial role in this process. Think of it as the brain's emotional filter. When we experience something frightening, exciting, or emotionally charged, the amygdala acts like a save button. It doesn't create memories on its own, but it signals the hippocampus and other regions to enhance that experience. During these intense moments, the amygdala releases stress hormones like norepinephrine and cortisol, which boost our brain's ability to consolidate memories. This is why emotionally charged events, whether joyful or traumatic, are often remembered more vividly than neutral experiences. Now, let's talk about the hippocampus. This remarkable structure organizes our continuous experiences into distinct episodes. Instead of recording every second of our lives, the brain segments our experiences into meaningful chapters. Changes in location, activity, or context mark these event boundaries, triggering stronger activity in the hippocampus and enhancing memory formation. Research shows that we tend to remember moments that occur at these boundaries better than those in the middle, allowing our brains to store experiences efficiently, grouped into episodes yet clearly separated. Memory isn't just about individual structures, it's also about networks. Several large-scale brain networks work together to coordinate memory selection. The salience network, anchored by the anterior insula and anterior cingulate cortex, detects behaviorally relevant information and shifts our attention to it. Meanwhile, the default mode network, which is active during daydreaming and self-reflection, is temporarily suppressed during encoding, allowing us to focus outward. Interestingly, the strength of connectivity in the salience network can even predict how well we'll remember emotionally significant experiences. Neurochemicals are also key players in determining which memories endure. Norepinephrine, released when the amygdala is active, enhances hippocampal function, but too much stress can actually impair memory. Acetylcholine heightens our attention and supports synaptic plasticity, which is crucial during learning. Dopamine, on the other hand, marks rewarding or surprising events, reinforcing their encoding. Together, these systems ensure that behaviorally relevant information is prioritized for long-term storage. At the cellular level, lasting memory relies on a process called long-term potentiation, where repeated activation strengthens synaptic connections. Emotional arousal, mediated by the amygdala, amplifies this process, ensuring that emotional memories persist. Interestingly, memory consolidation continues during sleep, particularly during slow-wave sleep, when the brain replays patterns of neural activity from recent experiences, reinforcing important memories while allowing irrelevant details to fade away. Novelty and contextual relevance also play significant roles in shaping our memories. When we encounter unexpected events, our brains strengthen the encoding of those experiences. Context matters too. Experiences tied to our goals or connected with past memories are more likely to be stored, helping us construct coherent narratives of our lives. Ultimately, the brain doesn't remember everything. It filters for meaning, emotional intensity, surprise, context, and relevance. Through this selective system, only the most significant moments remain with us for a lifetime, shaping who we are and how we understand our world.